all we are engineers, and that too communication engineers, we are having major role in the society. Why? Because without communication, nothing will move. If the communication is good, then everything is going to be forwarded. So that is the key importance of the communication. But there are dramatic changes taking place in the technology of the communication. At the same time, how these technologies are implementing in different platforms. Keeping these two objectives in view, we planned this workshop. The basic concentration of this workshop is emerging technology changes in communications. Second part of this is how they are ported into different platforms. Now we know that we are operating at big data technologies, which is at petabytes. We know, and we are operating with multi-resolution images and multi-resolution data in our homes, starting from micro oven to wash. We are using most of the gadgets operating with big data applications.
Just to take bunch of the ants, throw on that. The ants will eat that so that you can get it back. So whatever the voice, whatever the picture, this we can convert into digital signal. We can make it powder pieces. We can encrypt.
Dean Engineering and Management, Dr. Madhusudan Rao, to address the camp.
I am very surprised by looking the recent trends. Already you are rocking the world with your technologies, with your gadgets. Every day there is a change in the technology. The fastest growing technology in the world is, you know that obviously it is the your field, electronics. Every day we see some new technology in the world, every day. So what recent, if it is today you are discussing something, tomorrow it may become obsolete. Okay? So that means it is a big challenge for all of you to try to know the developments hour to hour, not days to days or months to months. So that is a real challenge for all of you. So that is possible when you keep your eye on the developments. Okay? Of course, to understand the developments, you need a lot of knowledge. So such knowledge you can get from these type of workshops.
Now I would like to request our Registrar, Ex-Commander Dr. M.S. Raghunathan, to please address the camp.
Having said that, I welcome all the delegates to this very important workshop and congratulate the EC department for having organized this very important workshop on communication technologies and signal processing. Why I am saying this, having done a big stint in the Indian Navy, and as very correctly Madam Usha Rani said at the very beginning of her address, nothing moves without communication. Today, all the three services, the Navy, the Army and the Air Force, communication is the key. The technology is the key at sea, or even the land, or even in the air.
It is on the occasion like this we get the opportunities to test our knowledge and understanding. We look forward to get an exposure about what the best of the brains think about this very dynamic issue in communication technologies.
To introduce Dr. N.S. Murthy, the main proponent of this program. Dr. N.S. Murthy is currently Professor in Department of History, NIT Warangal. The alchemy of this great man inspires and brings spirit of research in all our souls. He was graduated in Electronics and Communication Engineering from Andhra University.
But communication and signal processing is something really, it's a very big challenge. Especially the latest, the trends in communication technology, the several, the 4G as the speakers have mentioned, the 4G and beyond 3G and 4G, the wireless communication, various challenges, how several new coding techniques have come into picture. So all these are very challenging actually, and many people don't venture into this field. The least resistance path is taken by many teachers. But that should not be the case. Because if at all electronics and communication engineering, if we claim that we are ECA, it should be only communication engineering, nothing else. Of course, communication engineering encompasses everything. It encompasses digital signal processing, it encompasses statistical signal processing, encompasses VLSI, everything. 1930 or 20s, during that time, when Swami Vivekananda he was in America, he was talking to the scientists there. By that time, the wireless was not still invented or discovered. It was all through wires only. Then he made a statement to the scientists. You can read the complete works of Swami Vivekananda, volume 6 or 7. So it is given there, a footnote also, the author writes there. He says, you are communicating through wires. The fact that you are communicating through wires means that you do not know how to use the technology. If you can communicate without wires, then only you are a scientist. Otherwise, you are a surface scientist. That's what he said. You are a surface scientist. The fact that we are not able to communicate without wires doesn't mean communication is bad. We are bad. We are not able to, go deeper and do the communication without wires. That's what he explained to them. Because at that time he was explaining the yogic technique of transmitting information from one mind to another mind. And he said clearly, without wires, we should be able to, and that's what the yogis were doing, telepathy. The telepathy is communication without any wires, external, mind-to-mind communication. And that's the ultimate goal. Each channel having 44 megahertz. So if you see the Nyquist rate, 88 megahertz sample rate is enough because channel bandwidth is only 44. So this leaves a lot of CPU performance to spare because 88 megahertz is not a big frequency for the CPU. CPU works at hundreds of megahertz. Now, we will see the evolution of SDR architectures. How first they started with 2.5G and then how it is getting evolved. First, if you see the current generation technology, there is something called reconfigurable hardware platform. So this is the key. Reconfigurable hardware platform, that is also called digital IF. Digital IF. So what we do is, in the digital baseband, normally, you take the I and Q channels. I think you are all familiar with I and Q channels when you process the signal and then for down conversion. That means this processor here, it has to work. What is the burden of this processor? What is the computational burden? How fast it should work? That means you have to see the standards, and from the standards you have to derive the specifications and then see whether you can give the reconfigurable infrastructure for running those things in real time. So that is the key. The software architecture is something like this. So you have higher level protocols, then radio applications, link layer protocols, etc. And the operating environment, hardware resource management, memory management, etc. And hardware resources like DSPs, FPGAs, microprocessors, memory, and then analog RF hardware. So this is software architecture, what we have put here. So if you see the actual components there, you will be using all of these things. The FPGAs, microprocessors, and then the operating environment performs hardware resource management activities like allocation of hardware resources to different applications, memory management, interrupt servicing. So the typical components, therefore, in an SDR, if you see, there is an analog radio frequency transmitter receiver in the 200 megahertz to multi-gigahertz range. That analog, that means the RF stage, basically. Then high-speed AD-DA converters to digitize a wide portion of the spectrum at 25 to 210 megasamples per second. This is very important. The analog to digital converter and digital to analog converter, they normally the ADCs and DACs which you have heard or you have studied are all useless here. The 12-bit success approximation ADCs, dual slope ADCs, all these things will not work. Handling the protocols and then the other user-related issues, the microprocessors will be sitting there like ARM processor or PowerPC, and they will be handling your protocols. So they can run at a slightly lower frequency, but actual data transmission and the data conversion, modulation, etc. takes place in another hardware domain. So therefore you have DSP processors working, the ARM processor like processors working, and then the FPGA is also working. Several layers of this hardware you have to handle. We will see a few of them soon. Well, some of these things are, for example, the Xilinx Virtex 4 FPGAs have embedded 405 power processors. That is, nowadays the FPGAs are coming with a lot of resources. So the FPGAs have wonderful microprocessors, microprocessor resources available in that. For example, PowerPC itself is, as a core, it is available, or ARM core is available in the FPGAs, and there are several other things also available in FPGAs. The Intel Core 2 example, high performance math core special signal processing with special signal processing instructions is available. Texas Instruments 320C67XX series. These are all high performance DSP processors which can be used for handling some of the SDR activities, not all. System level functional partitioning, digital frequency conversion partitioning, a COTS implementation of the basic architecture, and finally conclusion. COTS means what? COTS, commercially off-the-shelf components. So you can, when your microprocessors and DSP processors are not able to meet the demand, some functions can be implemented using commercially off-the-shelf components, which are very function specific and very fast. So those things can be purchased and then you can integrate this into the system, like what defense fellows do. They have used completely this hardware platform up to 10 megahertz. They have brought down the RF by 2 stages of IF, 2 stages of mixing, and then they handle the whole thing in digital. But here also you have, actually there is no down conversion here, you see. See, the point you have to remember is how they are slowly evolving. In this particular scheme, the whole down conversion has been done only in analog domain. There is no digital down conversion. Okay, so you have down converted everything up to 10 megahertz, and then 10 megahertz ADCs are available. So you digitize and then you do your processing. So now, coming to the basic software defined radio block diagram, why DSPs will not be cost effective? Performing all the equivalent baseband functions for 3G with current generation DSPs is not possible. I will give you some figures.